Hello everyone, today I'm PK1 Muhammad Azim Muhammad Razi. Today we're gonna solve a problem about regarding transition. They have two questions. Okay, now we're gonna look at question number one. Question number one said, for each transistor show, determine whether the BE and BC junction are toward or reverse based and determine the operation region. So what is BE and what is BC? B is for base, E for emitter, and C means collector. Okay, this is the answer for question 1. For question 1, we need to find a types of transistor, forward or release bias, and the region. Okay, the first question is the type of transistor is PNP because it's going towards B. So we already got the value of VBE. So to find the value of VCE, we need to use formula VCB plus VBE. So VCB equal to VCE minus VBE equal to 4 minus 0.6 equal to 3.4. So as we know, if the value is positive, we can conclude it as a reverse bias. And for VBE is forward bias. After guide a forward bias and reverse bias, we conclude if this transistor is active regions. Okay, for the B, it is NPN transistor. It's because the current flow is going through emitter. Okay, we need to use the same formula as a question number 1. So we got 0.2 minus 0.7 equal to negative 0.5 voltage. So always we know if we get a negative value, it will be reverse bias. And also for VCB equal to the value is 0.7 is also reverse bias. And we can conclude as this as a cup of regions. So for the C is same as B, so is NPN transistor. Okay, now we need to find the value of between voltage C and B. So we use the formula VCB equal to VCE minus VBE equal to 0.3 minus 0.7 equal to negative 0.4 voltage, and it is a forward bias. So the for VBE is positive value, so it gonna be forward bias. Both are forward bias, so it will become saturated regions. For D is same as A, so it's a PNP transistor. For the question, we need to find a voltage between B and E. So to find VBE, we need to use the formula VCE minus VCB. That means equal to 5.4 minus 0.6 equal to 4.8 voltage. And it also known as forward bias. For the value between voltage C and B, the value is 0.6. It's positive, so we know as a reverse bias. So in this case, we have one reverse bias and one forward bias. So it is active regions. Okay, we have finished the first question. Now let's solve the question number 2. Okay, for the question number 2 is already give our the voltage between EC and the current of IB. Question number 1, we need to find the value of resistor B, resistor C, and resistor E. After calculate the value for RB, we got 8 kilo ohms. For RC, I got 4 kilo ohm, and for RE, I got 2 kilo ohms. Number 2, they asked me to find the value of beta, current of collector, and current of inverter. For this question, we need to use the formula of Kirchhoff's voltage law. So we start from battery voltage. So we're gonna use the formula 10.7 voltage minus IA. So we need to use the formula. So 10.7 voltage minus IE RA minus VEC minus ICRC equal to 0 voltage. After that, we reform the formula. We can get VEC equal to 10.7 voltage minus IE RA minus ICRC. So as we know, IE equal to IB plus beta IB and IC equal to beta IV. So after we insert the value, we can get VEC equal to 10.7 voltage minus bracket IB plus beta IB bracket RE minus beta IB RC. And we calculate the equation and expand it, and at last we got the value for beta is 95. So we got the value of beta. Now we can find the value of IC. IC equal to beta IB. So we already know the value of IB and beta, so we just assume the value, and IC we can get the value of IC equal means 950 microampere. So after get the value of IC, now we can find the IE. IE equal to IB plus IC. So we assume the value. So IE we gonna got 560 microampere. For question number 3, we need to find the voltage between BC, voltage between CE, and voltage between BE. So for this question also, we need to use the Kirchhoff's voltage law. So it start from 10.7 volt minus IA RE minus V voltage between EB minus IB RP equal to 8 voltage. So we assume the value in the formula. So we get the voltage between E and B equal to negative 0.7. We already got the value of voltage between E and C equal to 4.98 voltage. If we look back at the resistor, we can calculate as a negative value. So in the end, we can get the answer of voltage between B and C by use the formula V BE plus VEC. So the answer for the value VEC is and the final answer is 4.28 voltage. For the fourth question, we need to determine the junction of BC and BE, which means it forward or reverse bias. From this, we can determine for the negative value, we can determine it as a reverse bias, and for the positive value, we can determine it a forward bias. So the answer is BC junction is reverse bias and BE junction is forward bias. So for the last question, as we know, if got a reverse bias and forward bias, the answer is a relative region. Okay, that's all from me. Thank you, sir.